Hi, good morning. Today we are continue to solve word problem. This question had a related rate problem and with other kind of topic together. So let's take a look at question number 1. The twice differentiable function W models the volume of water in a reservoir at time t, where WT is measured in gigaliter. 1 gigaliter equal to 1 billionth of liter, and T is measured in days. The table above gives values of W prime of T sample at various time during the time interval T between 0 and 30 inclusive days. At time T equal 30, the reservoir contains 125 gigaliters of water. Use the tangent line approximation to W at the time T equal 30 to predict the volume of water WT in gigaliters in the reservoir at the time T equal 30. Show the computation that lead to your answer. Okay, part A. So we do tangent line approximation. So we think of y equal to mx plus b. So we need to find out what is the x value or the t. So in this case, t equal to 30, and to the function wt, to this function that help us to give us the y value. So now y equal to w of 30 to wt, so y equal to w of 30 because t equal to 30. Now w of 30 equal how much? So the question said that at t equal 30, the reservoir contains 125, so therefore you get 125 GL. And then m had also relate to this function, is at 2 the w of t, so m equal to w prime of 30. So now we have to find the w prime 30 from the table, so we got 0.5. So now we have the information. So you have the t, the y, and the m. So y equal to mx plus b. You can use mt plus b. So now we got 125 equal to m is 0.5 and the x is 30, m plus b. So now you calculate this, you got 15. Now you subtract 15 both sides. So we got b equal to 110. So therefore the tangent line is y equal to 0.5 t plus 110. So the question asks to use this tangent line to approximate the WT in the reservoir at t equal to 32. So we're going to approximate W of 32. And then you substitute 32 into t. So we get 0.5 times 32 plus 110. So 0.5 times 32 is half of 32. Okay, so now we are going to add them together, so you get 126 GL. So W of 32 is approximately 126. So we finished question part A. Now let's go to question part B. Part B. Use a Lab-Raman sum with 3 subintervals indicated by the data in the table to approximate the integral 0 to 30 w prime t dt. Use this approximation to estimate the volume of the water WT in gigaliters in the reservoir at t equals 0. Show the computation that lead to your answer. So now we have to do Lab-Raman sum. Okay, so let's take a look at here. So we need to find the integral 0 to 30 w prime of t dt. So it's very important that you see it match. Sometimes you may have a table that with more than one function over here. So this w prime t, so you have to match w prime t and w prime t. This is the function that you had to use. So here there's only one table to make it easy, w prime t, w prime t. So this is the value that we're going to use as the y value. So now we're going to use 3 subintervals. Okay, so Lab-Raman sum. So it's going to be delta x times the height. The height will be the y values. Okay, in this case it will be w prime t. Now we're going to see what are the 3 intervals given to us. 0 to 10 will be the first one, and then 10 to 22 will be the second one, and then 22 to 30 will be the third one. So now delta x, so you subtract, okay? 10 minus 0 is 10. 22 minus 10 equal 12. 30 minus 22, you get 8. So now this part, okay, you have to be careful with. It's a left-Riemann sum. 0 and 10, which one's on the left? 0. So this is the one that you're going to begin with, okay? So now this will be the first left. And then 10 to 22. 10 is on the left of 22. So the 0.7 will be the second left. And then 22 to 30. 22 is on the left. So 1 is going to be the third left. So now we are going to calculate using base times height. So now you're going to have 10 times 0.6. And then 12 times 0.7. And then 8 times 1. Now we're going to calculate. You can use a calculator. Okay, so you get 6 plus 8.4 and plus 8. Okay, so now I like to add these two together. So I get 16.4, 6, and then you get 22.4. So the question gave us the unit. If they never give you the unit, what do you do? So you use the unit of the integrand, multiply the unit of the dt, then you can get the unit. So the unit of w prime t equal to GL per d. And the unit of the dt, which is the time, okay, is in days. Okay, and then you multiply them. GL per day multiplied by day, and then you cancel. You get GL. So therefore, update the calculation. So the unit is going to be GL if the question never give you the unit. Now, we finished doing the approximation. Let's go back to the question. Okay. It says that use this approximation to estimate the volume of the water WT in gigaliters in the reservoir at t equal to 0. So next we need to find W of 0 and show the computation that lead to your answer. W of 0, you get 0 to 30. The first thing you should think of, W of 30, and it's given to us in the very beginning. At t equal to 30, you had 125. So W30 equal 125. So for those people who have been reviewing, to see that there's a relation between W0 and W30 in this integral. The relation is the FTC. So integral 0 to 30 W prime of t dt equal to W30 minus W of 0. So derivative, antiderivative, this is the FTC. So now we are going to use our answer 22.4 to help us to get the answer as the question asks you to do. And then W of 30, and then your minus W of 0. Now we just solve for the W of 0, so we just do our regular computation. One more time, if you're allowed to use calculator, you definitely use your calculator. And in this AP exam, you're allowed to use calculator for all the questions. So we subtract, so we're going to get negative 102.6. And then they divide by negative both sides. And the unit is GL. Because W has the unit of GL. And W has a unit of GL. You subtract, you get GL. And definitely this is the unit of GL. So we finished finding the W is 0. And we finished part B. Now let's go to part C. Part C. Explain why there must be at least one time t other than t equals 0 such that W prime t equal to 0.7 GL per day. When you read this, okay, it sounds like the mean volume. It also sounds like the intermediate volume. These two volumes are usually together, okay, when you have this kind of problem. This one, let's see which one fit, okay. So now let's take a look at the data first. We want to find out, okay, other than t equal 10, you get 0.7. So besides this, can we prove w prime of t also have 0.7? Because this data is w prime t and w prime t. They don't have the relation of derivative. The mean value theorem, you should use the slope. So over here, you already had w prime t and you had w prime t. So we should try the intermediate value theorem first. So now 0.7. Is this 0.7 between 0.6 and 0.7? No. Okay, 0.7. Is it 0.7 between 0.7 and 1? No. 0.7, is it 0.7 between 1 and 0.5? Yes, because the w is a twice differentiable function. So if you have a 1, in order to go down to 0.5, it has to pass all the number between 1 and 0.5. Okay, like 0.9, 0.8, 0.7, 0.6. Okay, so we found the interval. So using the intermediate value theorem work. Now we are going to say box C. We got w prime of 22, because of 22. Okay, so we had w prime 22 equal to 1, and then we had w prime of 30 equal to 0.5. 0.7 is between 1 and 0.5. So by the intermediate value theorem, there is at least 1 t, and t is between 22 and 30, 22 and 30, such that w prime of t equal to 0.7. So we finished part C. So we found the theorem, and we prove it in the interval 22 to 30. There will be at least one time w prime t will pass the 0.7. Okay, so now let's go to part D. Part D. The question said that the equation A equal to 0.3 w2 third, okay, equal to 0.3 times w2 to 2 third, gives the relation between the area A in square kilometers of the surface of the reservoir and the volume of the water WT in gigaliters in the reservoir. Find the instantaneous rate of change of A in square kilometers per day, with respect to T when T equals 30 days. So now we are going to see what it means by this area. So the reservoir is like a pond, it's a gigantic pond. So this is going to be the area, and then there will be the dip. Okay, so you can say the height. So now we are going to say A equal to A of t. You need to find the instantaneous rate of change of A. So that means you have to find A prime of t at t equal to 30. So in other words, find A prime of 30. So now we are going to use the equation given to us. That is a formula given to you. So you have to use this one. You don't have to derive any formula. So we have A equal to 0.3 W to the 2 third. We're going to rewrite into A of t equal to 0.3 each a function of time. So now we are going to differentiate with respect to time. So A prime of t equal to 0.3. Numbers stay the same. We put the exponent 2 third in the front, and then times here 2 third minus 1. So inside we still get the W of t, and then multiplying the derivative of the inner, so it'll be W prime of t. So we use the chain rule over here. We reviewed it before. So before I substitute the t equal 30, I'm going to simplify a little bit first. So fraction, I'm going to convert this into fraction. And then this will be negative 1/3. And we can simplify here. You're going to have 1 over q root of W of t. Okay, now we are ready. So we put a prime of 30. You get 1/5. And then you're going to get q root of W of 30 times W prime of 30. So we know that this one over here, W prime of 30, we found it before. At t equal 30, there were 125. So you could become q root of 125. And then W prime of 30 is 0.5 from the table. So now we're going to simplify. So we got q root of 125, we got 5. And then I'm going to convert it to fractions, make it easier to multiply. So now you get to multiply 2 times 5 and then times 5, so you get 50. So 1 over 50. And then this is 2-dimensional, so therefore it had to be something square, and km squared per day. Okay, so we finished question number 1.